going to go into the methods that we came up with for testing for a persistent seed bank. I'll define a persistent seed bank for you. And the results that we found and the future research that we need to do in case any of my classmates are interested. So we selected these sites based on the availability of the sites, as well as we wanted to encompass the entire Humboldt Bay, both salt marshes in the North Bay and South Bay. And we wanted to have at least mainland sites and island sites. So we chose Mad River Slough Island site, Jacoby Creek mouth, Woodley Island, and Elk River mouth, and South Spit. So we had a grid superimposed onto air photos using ArcMap. And from there, we had a randomly generated start. And then we had systematic placement of 20 high marsh plots that we categorized as having less than 30% Spartina, and 20 low marsh plots that we categorized as having over 60% Spartina cover, for a total of 200 samples. Once we came to this is an example of the plots that we chose. This is at Jacoby Creek. Once we came to a plot, we would measure, estimate percent cover of vegetation by species using a 1 by 1 meter quadrat. And then within those plots, we had subplots that were 30 centimeters squared, and we would clip all the vegetation, mainly the Spartina, down to the ground so that we could place screens on top of the 30 by 30 centimeter square area. And this is, if you have heard my talk last year, this is a next step that we decided to take because it turned out the method that we were using before, we kind of started to start the program later in the season when the seeds were starting to drop already. And so we had to cut off the first half of centimeter of each sample. So we didn't feel that we got a good estimation. We actually underestimated the seeds. So to define a persistent seed bank for you, this helped. The screen would keep we would know that, sorry, I gotta look at my, plots visited during this time, July and August, and that way we knew that there's this from the seed set of 2009 and earlier. So we for sure knew that we were looking at this persistent seed bank versus an ephemeral seed bank, meaning that the seeds came from this year. So we cut our 10 by 10 centimeter square sample with a saw, and we cut 4 centimeters deep based on the methods that we produced last year. And then we removed the chunk of soil and put them in labeled plastic bags. And then we had to do some maintenance of reclipping the vegetation to make sure that the screens wouldn't have holes. And we replaced any of the lawn staples or replaced screens as needed so that we could keep going back every year and test the longevity of the seed bank. Samples were stored in the refrigerator. And then each sample, one at a time, we rinsed with water using a hose and a nozzle, and then we would break up the clay with our hands a little bit further, and then we would rinse them through a sieve, a series of graduated sieves. The first sieve was 5 millimeters, and then 2 millimeters, and then 1 millimeter. We found that the 1 millimeter sieve was small enough that the Spartina seeds couldn't get through. They're at least 1 millimeter thick. And that's us looking for the seeds. Most of the seeds we found on the top sieve, the 5 millimeter sieves, and we found that the best method, we were using tweezers right on the sieve to kind of go through all the material and find seeds, but we found putting a little bit of the sample on a plate and pouring water over it helped to disperse the materials, and it was easier to find seeds, so we kind of enhanced that a little bit. And damaged seeds were thrown away, as well as empty seed coats, and then all seeds were placed on a damp paper towel and put in the fridge in a small plastic bag. So our results were that we did confirm a persistent seed bank for all the sites and primarily in the low marsh. So mean density of low marsh was around 1,500 seeds per meter square, and high marsh was 15 seeds per meter square, so that's a big difference. And correlation, we found a correlation between Spartina cover and seed bank density. Seed density was also varied among the sites, as you can see. There is a significant difference between every site, and we only tested the percent cover of vegetation at seed site as our only independent variable. So there are many other variables that could influence the differences in seed bank densities among the sites that we didn't measure. Spartina cover was in the low marsh, always dominant, and was highest at Jacoby Creek and lowest at South Spit, as you can see. And Jacoby Creek and South Spit were also highest and lowest for seed bank density. So rapid sedimentation at Jacoby Creek between the 1970s and 1990s due to timber harvest in the watershed might explain the robustness of Spartina at Jacoby Creek, because unlike low marsh areas around the bay, Jacoby Creek salt marsh formed after Spartina was well distributed in the bay. The influence of fresh water from Jacoby Creek probably also gave an additional competitive edge in colonizing the site before native species could establish. And high deposition rates at this site could also facilitate Spartina seed incorporation into the seed bank. Overall, Spartina seed bank abundance appears to be driven by the abundance of standing Spartina. So the future research needed, in case anybody's interested, we're going to continue with the already established plots and keep going back and sampling and seeing if there's a change in the amount of seeds that we found. We already found, as you saw before, we guesstimated over 6 million seeds per acre in the low marsh anyway, so that's a lot. And we want to see how many years do those seeds stay in there and stay viable. And we also are interested in how the seed bank behaves after being mowed, and we're working on another study with that. And we are interested in the buoyancy of seeds, like first of all, how do the seeds float, and then where do they stand in the water column, where are they most found? And then the longevity of seed viability in the inflorescence themselves and in the rack and in seawater, because that's important, say for Andrea's talk. You know, we have all this rack of Spartina that we're putting in the bay, so how much of the seed impact is there going to be there? And then how much of the Spartina emerging on salt marsh is from the seed bank versus the seed range? So we have plots out there already with screens that have been mowed down already, and then screens were placed in, and then some plots right next to the screens are left open, and we're going to see if there's a difference between seedlings coming from seed rain versus just the seed bank, from either plants immediately at the site, plants off-site dispersed by tides, and transported by rack. And this is a small list. There's many more people that have helped, but I want to thank Ben Bridegroom and Anna Cantor, Jessica Graff, Zach Grazel, Heather Lagarde, Luke Lagarde, and Laura Morgan and Rachel Olive. And these, Laura Morgan and Rachel Olive are just volunteers, and I really highly recommend volunteering. Help me out over the winter break, because we're going to be starting our second year of the seed bank study. So that's it. Thank you.